Are you ready? No, really, are you ready? Because we are officially starting chemistry, and I am super pumped. So we are starting by talking about matter this week. So today is all about the types of matter, and then we'll get a little more detailed in next week's lessons about elements. So first of all, matter is anything that has mass and takes up space or takes up volume. And what we're going to be doing today is kind of dividing matter up into smaller and smaller things. So first of all, matter is divided into pure substances or mixtures. So what is a pure substance? Well, it's something that cannot be broken down by physical means. So there's nothing that I can do to it physically to make it any simpler than it already is. So substances, or pure substances, are going to divide into two other categories, elements and compounds. So elements are things that are only made of one type of atom. So not only can I not break it down by physical means, which is what makes it a pure substance, but I also can't do any chemistry to it to break it down anymore either. So like if I had a chunk of gold, I can't make that do anything to be something simpler than just a chunk of gold. And what makes something an element? One easy way to tell is it located on the periodic table? If so, then it's an element. Compounds are where we have more than one type of element chemically bonded together, and they're in a set proportion or a set ratio. So as an example here, one that you probably already know is H2O is water. It's a combination of two hydrogens and one oxygen together. If I change anything about H2O, if I change the letters or if I change the numbers with it, like H2O2, sounds really similar, but it is actually a totally different compound. In this case, it's hydrogen peroxide. Now, another thing about compounds is that I still cannot break it down by physical means, because that's what makes it a pure substance. But what I can do is do chemistry to break this down. I can't make the hydrogens and oxygens separate physically, but I could do some chemistry to it to actually separate those things. One other thing about compounds that we need to understand is that they are totally different when they come together as a compound than when they were individual elements. So a really good example of this is looking at sodium and chlorine combining. Now, sodium is an explosive metal. If I put it in water, it actually catches on fire. Chlorine is that lime green poisonous gas that you see pictured there. Two totally dangerous things, but when they chemically combine into a compound, guess what they make? Sodium chloride, table salt. Now, table salt is not explosive. Table salt is not a lime green poisonous gas. So it has totally different characteristics as a compound than it does as the individual elements. Now let's switch gears and talk about mixtures. So mixtures can be separated by physical means. That's the big difference between pure substances and mixtures. And we're going to have two big words for the two different types of mixtures. The first one is heterogeneous mixture. That is a mixture where you can see the different parts. They're very different from each other. So an example of this is a salad. Now looking at that salad, I see tomatoes, lettuce, cheese, chicken, salad dressing, a little bit of bacon in there as well. I can see those things. So that's one part of it being heterogeneous. The part about it being a mixture is, let's say that I look at that salad and decide that I don't like tomatoes. I can easily, physically separate those tomatoes from the rest of the salad, which is what makes it a mixture. A homogeneous mixture looks the same all the way through. Sometimes it's called homogeneous mixture, sometimes it's called a solution. But what's important to understand, and this is weird, even though it looks the same all the way through, you still can physically separate it. So let's talk about Kool-Aid. That's got water, sugar, and the Kool-Aid mixture. Now, once I mix all those things together, I shouldn't be able to see those 3 individual parts. It should look the same all the way through. But could I still separate it out? Well, yes, because it's a mixture. So it would be weird, but I could boil it and the water would leave, or I could evaporate it by leaving it out for a long time. One way or the other, it's important to understand that you still can separate homogeneous mixtures. So when we're talking about matter, we're going to use physical and chemical properties to describe it. So physical properties are things that you use pretty much your 5 senses to figure out. So you can observe it without actually changing the material. So looking at that bird seed there, I could talk about its color. I could weigh it out and talk about its mass. If you're talking about something that is currently a solid, what temperature does it melt? Those kinds of things we can do without really changing the matter. I can use those differences to separate out mixtures. So looking at that picture of birdseed, what are some ways we could separate it? Yeah, we could use color. We could use tweezers to separate out the yellows from the tans from the black. I could use like different size of screens so that the really small stuff falls through and the bigger stuff gets caught. Those are physical properties that I'm using to separate out that mixture. Now we need to talk about physical changes, changing the matter, but we're just changing its physical properties. So one example of this is changing size and shape. So looking at those 4 pictures, what are they pictures of? Well, they're all different pictures of paper, but what's different about them are their sizes and shapes. So they might have different physical properties, like they might have different masses, but ultimately at the end of the day, it's still just paper. Another example of a physical change is changing the phase of matter. So looking at that picture in the middle, we know that that's a glass of water. We know already that that's H2O. So when we look at the ice cube, it looks different, it feels different. We would use different words to describe it, but it's still ultimately just water. It's still H2O. Same thing with the steam, the boiling water there. It's still H2O, even though it looks different and has different physical properties. Now, chemical properties, on the other hand, I like to think of as what ifs. Hey, what would happen if I set this on fire? Or hey, what would happen if I put this in acid? Or hey, does this thing explode? Those are all chemical properties. But the thing is, if I do any of those things, it is permanently changing that matter. So like the iron nails there, if they're exposed to time and to oxygen, they will actually corrode into rust. So iron is corrosive and it changes to a totally different substance, iron oxide, because it's been exposed to oxygen for a long period of time. It's not the same iron nail that it was before. Chemical changes, or really most of the time called chemical reactions, that's when we're actually changing one substance to another. And there's a lot of signs that this is happening. Sometimes when you mix them together, they change color, like you can see the yellow there in the picture. A gas forms, you get a solid forming, a precipitate, which is what that picture is of. Sometimes all of a sudden the beaker feels hot or it feels cold. So all of those are signs that we've had chemical reactions happen. And that kind of summarizes where we're headed. We're going to talk about elements next week, compounds after that, and then chemical reactions after that. So hopefully this preview helped you kind of know where we're headed through the rest of the semester.